Hello everyone, Kotongwane, the native god here. Today I'll be taking you through question 3 of the Engineering Science and 3 exam that was written on the 31st of March 2023. Now question 3 is based on forces, and forces is quite a fascinating module in Engineering Science and 3, because this is where you get to truly apply conditions of equilibrium, including the triangle law. In fact, would you consider the triangle law a condition of equilibrium, or would you say it is a principle we use in conjunction with the conditions of equilibrium? Anyway, I'll leave the question to you today, and we'll discuss further and go into detail when we go through forces in a lesson in one of the videos I'm going to post later. Right. Question 3.1. Give one difference and one similarity between an equilibrant and a resultant force. Now, this one is pretty easy, pretty straightforward. It's 2 marks. They want us to determine the difference and one similarity between a resultant and an equilibrant. Right, so the difference is that they differ in direction, right? And then the similarity is that they have the same magnitude. Pretty simple, pretty straightforward, right? Now, of course, we'll go into much detail when we go through a lesson when covering forces, or the module on forces. Right, so stay tuned for that. Hit that subscribe button and notification bell so that you don't miss out on that video. Right, 3.2. 3.2 reads as follows. Use figure 2 to calculate the magnitude and direction of the resultant force. So we're looking for the resultant force of the forces acting at the point. Right, now we have a coplanar and concurrent forces, right, acting here. So we've been tasked to determine the magnitude as well as the direction of the resultant force. Right, now in order to do this, let's redraw what's on figure 2. Let us redraw what's on figure 2. Right, so this is what is on figure 2. Right, okay. Now, if you have coplanar and concurrent forces, and we are required to determine the magnitude as well as direction of the resultant force, remember what a resultant force is. A resultant force is what is the vector sum of forces acting on a body. Right, now in order to have the vector sum of forces acting on a body, we have to have forces that align with the Cartesian plane. Right, now if you look at figure 2, which is what we've drawn here, you have 2 forces that are aligning with the Cartesian plane. So by forces aligning with the Cartesian plane, I mean we need to have forces that are parallel with either the x-axis as well as the y-axis. Right, so the 100 Newton force as well as the 80 Newton force are both aligning with the Cartesian plane, so we can use them. Right, but the 120 force, which is the blue force here, and the 60 Newton force are both oblique forces. Now, what do we do with oblique forces? In order for us to be able to calculate the magnitude, right, and resultant the magnitude as well as the direction of the resultant force, right, we need to resolve the oblique forces into their components, so the vertical component as well as the horizontal component. Now the horizontal and vertical components of oblique forces will align with the Cartesian plane, hence we can use them when applying conditions of equilibrium, right? So let's get the components of the force 120 newtons and the 60 newton force, which are both oblique forces, right? Now to resolve the forces, we are going to have, or we're going to need to complete a triangle of forces, right? So you're going to have that horizontal component as well as okay, let's fix this. Right, fix that. Right, now in order for us to get the components, we need to complete a triangle of forces, right? So this here would be the vertical component of this force, right? Now as far as the direction of the components, right, the direction of the components of the oblique force must always be such that they go in the direction, or they follow, or they go in a direction that is towards the oblique force, right? Now the oblique force is in this direction, right? Hence the vertical component will be such that it is going towards this direction, as well as the horizontal component must also be such that it is going towards the direction of the oblique force, right? So here you have your horizontal component, which is what? Now the horizontal component, you have to look at it with regard to the angle, right? So here's the angle that we're using, 30 degrees. The angle is such that it is what? It is adjacent towards the horizontal component. So we are going to use cos for it. And then the vertical component is opposite the angle, so we're going to use sine for it, right? Now the horizontal component is headed west, right? And remember, forces are vectors, right? So we have to take into consideration the direction of the force, right? Now forces going upward are taken as positive, forces going downward are taken as negative, forces going east are taken as positive, forces going west are taken as negative, right? So if you look at your horizontal component is headed west, so we take it as negative, hence you're going to have negative 120. This side is adjacent to the angle, so you're going to have cos 30 degrees, right? And then the vertical component is headed south, right? And south is what? Negative. Hence the vertical component is going to be negative 120. This side is opposite the angle, so this will be sine 30 degrees, right? So we are done with what? With resolving the 120 oblique force. So we move on to the other oblique force, the 60 newtons oblique force, and we complete the triangle of forces here again by having a horizontal component as well as a vertical component, right? Right, so again, as far as direction, the direction must be such that it follows or goes towards the oblique force, right? Meaning the horizontal component must go towards, as far as direction, must go towards the direction of the oblique force. And in order for that to happen, the horizontal component has to go in that direction, right? So the vertical component also must go towards the direction of the oblique force. Hence, the direction of the vertical component will be south, right? Right, so again here, this is the angle we'll be using, right? And then if you look at the horizontal components, the horizontal component is such that it is adjacent with the angle. So we're going to use cos for it. So this, the horizontal component is going east. So this will be positive 60 cos 30 degrees. The vertical component is headed south. So it's going to be negative 60. And it is opposite the angle 30 degrees. So therefore we're going to use sine, right? Now we have resolved both the oblique forces, hence we no longer need the oblique forces, right? As you can see, all the forces now align with the what, with the Cartesian plane. Hence we can apply the conditions of equilibrium. Conditions of equilibrium being what? Being sum of forces in the x direction are equal to 0, as well as sum of forces in the y direction are equal to 0, right? So first, let's look at sum of forces in the x direction. So sum of forces in the x direction is equal to what? Is equal to, now forces in the x direction, you have what? You have this horizontal component, you have the 80 newtons, and you have this horizontal component, right? So you add them up. So this will be 60 cos 30 degrees minus the 120 cos 30 minus the 80. And this is equal to, so if you punch that in your calculators, you're going to get 131,962, right? These forces are in newtons, therefore newtons. Remember the sign, right? The sign tells us the direction of the force, right? Meaning, since this is a force in the x direction and it's negative, it means this force is going where? Is going west. So this is actually equal to 131,962 newtons west, right? And then we look at sum of forces in the y direction, right? Sum of forces in the y direction. Sum of forces in the y direction, we have the 100 Newton force, right? And then we have this vertical component as well as this vertical component. So you add those up, all of these forces are headed downwards, so all of them are going to be negative. So you have minus 100 minus the 120 sine 30 minus the 60 sine 30 degrees. So if you punch that in, we are going to get minus 190 newtons, right? Again, the sign indicates the direction of the force, right? So meaning the sum of forces in the y direction are actually equal to 190 newtons south, right? Now once you have once you've applied conditions of equilibrium and you have both the sum of forces in the x as well as y directions, right, you then complete your parallelogram of forces so that you can determine the direction as well as the magnitude of the resultant force, right? Right. So you have your Cartesian plane, and then on your Cartesian plane, you have the sum of forces in the y direction, which are going west, and the magnitude is 131,962 newtons, right? And then a sum of forces in the y direction are headed south, and are 190 newtons in magnitude, right? So from here on, you then complete your parallelogram of forces. So you're gonna have this to complete your parallelogram, right? And then you have your resultant right there, right? That's your resultant, which we still need to determine, right? Right. Then there you have your direction as well. Right, so let's determine the magnitude of the resultant force. Now, as you can see here, with your parallelogram, right, a parallelogram is such that the opposite sides are parallel as well as congruent, right? So this side is parallel with this one, right? And then this side, of course, is parallel with this one. The sides aren't just parallel, but they are congruent. Meaning what? Meaning if you were to superimpose the side that is parallel, right, if you were to superimpose this side you see that they are an exact match, right? Meaning in terms of magnitude, they are the same, right? In terms of magnitude, they're the same, meaning this side is equal to this one, right? And then this side is equal to that one. What does this mean? Again, once you've drawn your resultant force, right, you're gonna get it basically splits the parallelogram into two triangles. Now those triangles are also congruent, right? So meaning it doesn't matter whichever triangle you use, because you're gonna get the same thing, right? So we are going to use this triangle here, right, where we've labeled this angle as as theta. So we are going to take theta as our direction, right? And also remember, the triangles are right angle triangles. So to get your resultant, right, the resultant force, we use the Pythagoras theorem, right? And Pythagoras theorem is such that we need to get the square root of the sum of forces in the x squared plus the sum of forces in the y direction squared. This is equal to 131,962 squared plus 190 squared. And if you punch that in your calculators, we are going to get 231,331 newtons, right? That is the magnitude of the resultant force, and to get the direction, we need to determine theta, right? So which trig ratios are we going to use? We are going to use tan, right? Tan is equal to what? So tan theta is equal to what? Tan theta is equal to the side opposite. So the side opposite the angle is what? Is the sum of forces in the y direction. So sum of forces in the y direction over the side adjacent. The side adjacent is sum of forces in the x direction, right? So tan theta is equal to what? Sum of forces in the y is 190 over sum of forces in the x 131,962, right? We're looking for theta, therefore we need to determine the arctan of what? Of 190 over 131,962, and theta is equal to what? Theta is equal to 55,219 degrees, right? So there you have it. So R, the resultant force, is equal to what? It is equal to 231,331 newtons south, 55,219 degrees west. West, right? And there you have it. That is what there was. 4 marks, right? What is it? No, 7 marks, right? Very easy. So now we're going to look at question 3.3. 3.3 is based on roof trusses, right? 3.3 is based on roof trusses, right? So first 3.3.1, right? 3.3.1. So we need to calculate the value of P. So we're looking for the value of P, right? Now with the value of P, we simply need to, because we have the reaction on this side, right? We have the magnitude of the reaction on this side. We simply need to use Newton's third law of motion, right? Newton's third law of motion is such that forces going up is equal to forces going down. So sum of forces going up is equal to sum of forces going down, right? We're only missing one force, so we can determine the missing force, which is force P, using this condition of equilibrium, right? So we have P plus forces going up and Q. Q's magnitude is 45 kilonewtons, which is equal to forces going down, which is 65 plus 55, right? Therefore P is equal to what? So we're going to take 45 to the other side. 65 plus 55 is 120, right? Minus the 45. Therefore P is equal to what? 75 kilonewtons. right? So we now have the value of P. Easy 2 marks, right? Now we look at 3.3.2. 3.3.2, we need to calculate the magnitude and the nature of SR and WS. So we are looking for RS, which is this member, right? And WS is this member, right? Now if you look here, we have 2 members, right? And you have a joint here, right? And on that joint, remember the whole roof truss is in equilibrium, right? So it is a standard assumption that each joint on the roof truss is also being kept in equilibrium by each of the forces and members acting on it, right? So if we consider this joint, right, if you consider the joint, 3 forces are essentially acting on it, right? The force P, right, and member RS and member WS, right? So 3 forces are essentially keeping this joint in equilibrium. Hence we can apply the triangle law, right? Now the triangle law is such that if you have 3 forces acting on a body and those 3 forces are keeping that body in equilibrium, the 3 forces can be represented by sides of a triangle, right? And the sides of a triangle must be such that they follow a head to tail direction, right? Meaning, because we have 3 forces acting on this joint, we can represent these forces by sides of a triangle, right? So meaning, if we were to complete a triangle, so you have the force P, right? And then you would have RS as well as WS, right? This is a right angle triangle, right? You have force P, this size force P is 75 kilonewtons, so you have 75 kilonewtons there. Force P, we know the direction of it is headed upward, right? Remember what I said, that if you're going to be applying the triangle law is such that once you've completed the sides of a triangle, the sides of the triangle must be such that they follow a head to tail direction. So if force P is going upward, it means RS, so you have RS and WS, so it means RS is going in that direction, then WS is going in that direction, right? Hence you have a head to tail direction, right? Now to get RS and WS, right, we're simply going to use trig ratios, because what we have here is a right angled triangle, right? So to get RS is the hypotenuse of the triangle. Remember, we have this angle is what, 60 degrees. How do we know that? On the roof truss, so in figure 3, RS is making an angle of 60 degrees with what? With WS. So you have RS, you have WS, and they make an angle of 60 degrees, right? So we didn't just come up with this angle, right? We saw it on figure 3, right? So to get RS, remember everything has to be in conjunction with the angle 60 degrees, right? So 60 degrees is opposite 75 kilonewtons, right? So because it's opposite and RS is the hypotenuse, we are going to use sine. So sine 60 degrees is equal to what? Sine is equal to the side opposite the angle, so 75 over the hypotenuse. The hypotenuse is RS, right? So we cross multiply here. When you cross multiply, make sure RS is the subject of the formula, right? So when you cross multiply RS times sine theta, it's going to be RS sine 60 is equal to 75, and you divide by sine 60 both sides. So that goes, and if you punch that in your calculators, what are you going to get? We get 86,603 kilonewtons, right? That is the magnitude of the force in the member RS, right? Now what about the nature of the force? Now as far as the nature of the force, you always look at the direction, right? The direction of the member, right? The direction of member RS is such that, remember, you take this as your joint, right? So member RS, if you're taking this as your joint, is what is going towards the joint, right? So it is going towards the joint, and if a force is going towards a joint, you take that force as being compressive, hence you call it a strut. So this force is a strut or compressive in nature, right? Right, so now we look at the magnitude and direction of the member WS. WS is adjacent to the angle 60 degrees, right? And the side we have, which is this side, which is opposite the angle, is what 75 degrees. So in terms of trig ratios, because we're going to be using sides that are opposite and adjacent to the angle, we are going to be using tan, right? So tan 60, tan is equal to what? Tan theta is equal to the side opposite over the side adjacent, right? So the side opposite the angle is 75 kilonewtons, sorry, and the side adjacent is the side we're looking for, WS. Then you cross multiply here, WS tan 60 is equal to what? 75. So therefore now is equal to 75. We divide both sides, tan 60. So that goes WS, if you punch that in, is equal to what? 43,301 kilonewtons. That's the magnitude of the member WS. And as far as the nature of the force, again you go back to the triangular forces that we completed, right, using the triangle law, right? If you look at member WS is going away from the joint, right? And if you have a force and is going away from the joint, those forces are taken as tensile, hence we call them ties. So this is a tie. Why? Because it is tensile in nature, right? And yeah, there you go. That was 4 marks. Easy 4 marks. Now at this level we only look at what is this, the analytical way of doing solutions as far as roof trusses, right? But it is also very important that you know and understand the graphical method, so using Bose notation, right? Because even though you don't get to do it in engineering science N4, you definitely will be going through it in strengths of materials and structures, right? So if you're interested in knowing how to do the graphical method of solving trusses or roof trusses, hit that subscribe button as well as the notification bell, right, so that you don't miss a video based on such problems, right? This is Kotongwane, the native god. I trust everyone is okay. Good luck to everyone.